Hey guys, welcome to the stream. So basically what we are doing is these are the arithmetic operators. So you can also do subtraction. We will call it difference is equals to n2 minus n1, for example, or n1 minus n2, and we need additional printf for that. Hey, welcome to the stream. It's good to have you here. Please type hello if you are watching. Difference is followed by percentage d, and then n1 diff variable that we can use the diff variable. So again, if I compile it and if I execute, so let's say 22 and then 11, and the difference is not working for some reason. That is because of this one. um, you can just say percentage f over there, and I will have to recompile because there was an error. And now you get the difference as well. So do you see that the format specifier? So if I do 0.3f over here, it will get 3 decimals, guys. Okay, so as you can see now, it will get up to 3 decimals. So do you see there are 3 zeros? That is because of 0.3f. Here we have 0.2f, means it will round it to 2 decimals. As you can see, there are 2 decimals after the whole number, right? That is the uh, thing. Okay, addition, subtraction, multiplication, division, you can do division as well. Div, I will just say div is equals to n2 divided by n1, and we'll have to print that as well, printf, and then the result of division is, and then percentage d, percentage f, sorry, comma, there. Again, save that and then run it. I will do clear screen over here, and I will do this. So let's assume I give it 50, and then 5. So you get the result of the division as well. Here what we can do is we can do slash n here and slash n over here, again 0.2f this time. Okay, and we will rerun that. 44 and then 3. So you get the result of the division as well, that is n2 divided by n1. N2 was 3 and the n1 was 44. You get the revision, you get the results. As you can see, this is very beautiful thing to practice. Okay, now the next thing is, We have local and global variables, constants, memory basics. Okay. So the next thing is this. So this program is to cover the local and global variables. Okay. Local variables, global variables, we already know what constants are, and we will cover the memory basics. So let's go ahead and do this program. Basically, we will create a new file. We'll create this file, and I will start with hash include studio.h, and then what I will do is I will declare a constant. This is a constant called as max. What I have done, we will do. So I will just say constant um, pi is equals to 3.14. I will just do that constant, and then what type of variable it is. Constant integer, constant float. Pi is equals to 3.142. They have taken an integer, I have taken a const. This is global constant. Okay, then we are declaring a small function. Okay, so this function will not return anything, so we will just say void, and then we will start the function definition. Void, what is the name of the program? So here it is print local, so I will just say the same name, print local. This name can be anything, but then for this particular program we are calling it print local. And here what we are doing is they are declaring an integer value, integer n1 is equals to 5. I will just declare that variable as 5, and this is a local variable. Okay, then we have printf. Okay, printf, and we say local x is equals to d and x. Okay, we are just basically what we are doing is we are putting the value of this to the screen. So the value of local variable n1 is, and then percentage d slash n, comma, the name of the variable itself, which is n1, and then we are declaring the global pi value is, and then in this case it is percentage point to f, comma, and then pi. Okay, okay, and then slash n again, just to be sure, which is nothing but a new line character. Okay, it will print it on a new line. Then that program ends. Now what we are doing is we are calling this inside the main variable, a main function. So over here in main, and then we will call the function. What is the name of the function? It is print local, and then we call it, and we will return 0 for success. Okay, so understanding guys what is happening. Very good, a warm welcome to you. Thank you so much for joining. You can chat and ask questions if you have any questions regarding this. So I will clear the screen to begin with. Then what I will do is I will say GCC 6, I will say dir. Okay, I will have to save this file, save as, say 2. Okay, now I can say GCC 6 dash o, and it will be 6.exe. Okay, it compiled successfully, that's the good thing. Okay, so as you can see, the value of local variable n1 is 5, and then the global pi value is 3.142. That is how you access the local and global variables. Here this is called as a local variable, and this is called as a global variable. The thing is, the global variable is accessible inside any functions. Okay, inside the main also it is accessible, inside the print local also it is accessible. But when it comes to local variables, the n1 is not accessible here. If I try to print n1, I will show you, it will return, it will be a error message. For example, if I say printf n1 is, and if I say percentage d, comma and 1. Actually it didn't even, it got compiled actually, but then there should be an error because I don't know what is happening over here, but it will be an error, that I'm sure about. Okay, you had seen that it was red over here, that means that there was an error. Okay, but due to some reason it didn't throw the error, it got compiled and it was just trying to find it. Okay guys, so okay, wonderful. Now the next part is the ASCII and typecasting. Okay, we will do this in a bit. Typecasting and ASCII, um, we will do this now. So what I want you to do is I want you to create a new file as always. So over here we will create a new file. I will call this ASCII underscore typecast.c. Okay, we have the program ready. I mean we have the uh, file ready. We will start doing hash include and then studio.h, and we will declare an integer main. Again this is returning 0 on success. Okay, now we are declaring a character called as ch, and inside which we are storing the value called a. Okay, we stored a into ch, and what we are doing is we are converting ASCII value into integer uh, part. Okay, explicit typecasting, this is called as explicit typecasting. So what we are doing is int ASCII underscore val is equals to, first let's try to copy this program. Otherwise, rather than writing, what I will do is I will just copy this program. So int ASCII val is equals to int of ch. So int of ch will be whatever number is assigned to it, that will be displayed when you just say ch. Okay, so first it will display a, and then it will display ASCII value, and it will display a number. Okay, then we have two variables x and y. One is initialized to 5.0, another is initialized to 2.0. So 5 divided by 2, we should get 1 as the answer. Let's see what happens. GCC, and then this is 7 dash O, and then exe, then 7 exe, see. So as you can see, the ASCII value of A is 65. If I change this to any other value, for example, if I type Z here, it will be different, guys. Observe this. Now the ASCII value of Z is 90. As you can see, it is printing 90 here. Earlier it has printed ASCII. Why? Because the character was A, now the character is Z. You can modify this a little bit and get the value from the user itself and then display it. That will be even more nicer. So we can do that as well. To do that, what we can do is we try doing that here. Okay, printf enter a character and then percentage d percentage c, enter a character percentage c comma ch in this case, and then scanf percentage c percentage c over here comma ch. Okay, and then actually this will be a little tedious for me to figure out, but for now we can just see what this is. uh, let's ask ChatGPT. I will show you what I want to do. So here, let's open new chat. Here I want to scan the value. Is this right? So up to some point it is right, but then so what I want to do is here, let's file and save this as one, and I will just do this. Let's do CLS first, and I want to see what this is. So GCC 7 typecast 1 dot c dash o to 7 typecast 1 dot exe, and then 7 typecast 1 dot exe. So here z is 90, which is fine. So let's say f, I put f over here. So it says you entered f, your ASCII value is 102. Do you see that? That can be done. So over here, so this time if I enter s over here, it prints 115. So I can remove some of these over here. First, what I want to remove is this. Second, what I want to remove is this. I want to remove this as well. Now this program should work technically, right? This should technically work. What we did is we removed all the garbage over here. So over here ch is erroring out. So what I want to do is I want to say cat ch is equals to okay. We'll just initialize it with a, and then technically this should work now. Enter a character w, and then the value is 119. Enter the character a, it should print 60, right? 97. I will enter capital A 65, yes, and then capital Z is 90, right? Yeah, it is working. So you can use ChatGPT sometimes. Okay. Okay. Yeah, this is working, guys. As you can see, it is working wonderfully. Okay, welcome to the stream. Thank you so much for joining. Hi, Sharmad, how are you? Sharmad, Ishaq, how is everything? What we are doing is we are learning C programming in 10 days, and we are following this chapter. This is the item that we are on now, input output. This is day 2, data types and variables breakdown. We are doing the classes for keywords. We covered all these things. We covered variables and declarations. We covered input output. We covered all these, and now we are at variable scope and simple calculator program. This is where we are at, and we are printing the ASCII for a particular character now, which is the last one. So if you have any questions, please ask. I will be here to answer. Sharma, do you have any questions about what we are doing? Okay, so that's about it. That is the last program that we are doing over here, and it is time to end this stream because we were able to cover the typecasting as well over here. We looked at memory and data representation basics. So thank you so much for joining. So we can end the stream now, and or we can continue. If you have any questions, I can continue the stream as well, right? So how variables occupy memory, you were able to understand how they occupy memory, right? And then you right now this program is the ASCII part. So ASCII value, this is how you go ahead and convert it to the ASCII value. You just say int of ch. So ch has a, it will be ch of integer value of a. If this is b, it will be integer value of b. If it is c, it will be integer value of c. If it is bb, it will be integer value of bb, right? If it is n, it will be integer value of n. So that's wonderful. Hi Ali, how are you? So basically what we are trying is the numbers, the character actually, whatever you are saying is right Ali. So the character over here, the character that you enter, I will show you. What Ali is saying is right. For example, what happens is here, if I enter the character as A, let's say if I enter the character as H, the value of the H will be displayed over here. So that scanf, that printf is telling you to enter the variable. We entered H and then we press enter. What happens is the scanf comes in and it will get the character ch. So here you can remove the statement actually, even then it will work. I wanted to show you that. So here you can just say cat ch, okay, and then you can directly do this, right? And then if I press F and if I get the value of F is 102. Understand Ali? What you say is right. You understand how ASCII is converted into numbers and numbers and ASCII into numbers using C++ program. We can do C++, but this is regarding C programming Ali, and we are doing the C program for that. So as you can see, it works, and you can enter any other value. For example, X, it will be 88. So this is how it is, okay? So you're welcome Ali. And it is great that I see that you are on the stream, you are trying to understand. This is actually the last bit where we are doing this memory data representation basics and concept of ASCII. So whatever happens is called as implicit typecasting. Whatever we did here is called as explicit typecasting. Here we are typecasting it to integer value. Originally it is a character value, we are typecasting it to an integer value. So wonderful. So now um, that's the end of the stream because we covered a lot of things. I can put this data sheet for you guys as well. So we have covered all these things. We have covered all these things. So first is day one, then we move to day two. Now we are doing all these things. We learned, just to summarize, we learned integers, floats, doubles, character, constant, keyword, modifiers, input, output, printf, scanf, and we were able to build a simple calculator as well. And why we should learn this? Variables store data. Without mastering them, you can't do arithmetic, text processing or memory management. That is why you need to learn these concepts that we covered in day 2. And what all were the concepts for day 2? The day 2 concepts were these things. Day 2 We started off with basic data types. We covered constants. We covered keywords. We covered type modifiers. These are very important. For example, signed can be negative or positive, unsigned can be negative or positive. I am asking you a question. Can this be negative? Can this be negative? Can this be negative? Can this be negative? We did double L, and we covered a program for that. That is for you to revise. Some are negative, some are positive. Then we have variables and initialization. We have input output. We covered that. We had arithmetic operations. We covered that. I didn't cover the modulus, but I will do that some other time. So we covered a simple calculator program. We did this with two numbers and multiple numbers as well. Then we looked at variable scope, and then finally memory and data representation. Thank you so much for joining in. And if you just came, we are almost ending the stream. Thank you so much. Um, have a nice day. I will do the day 3 tomorrow. Thank you so much. Have a wonderful day. Thanks, Ishaq. Thanks, Ali Ibrahim. Have a wonderful day. Bye bye.